This is the 4.1 to 4.2 review, and this time calculators are allowed, which is pretty nice. And our job is to find the critical values of x for the functions below. So let's keep in mind that in order to be a critical value, two things have to happen. You have to be in the domain, and the second thing is f prime of x has to be 0 or undefined. So if we look at part A, we can see that it's a polynomial, so the domain is all real numbers. That means we only need to look at the derivative to see when it's 0 or undefined. Y prime will be 12x cubed plus 12x squared minus 192 times x plus 240. All right, looking here, it's a cubic. I don't really want to factor a cubic by hand, so I can find the zeros by using my calculator, which is why my calculator is allowed. So to do that, I am going to first go to F2, and I'm going to solve for when 12x cubed plus 12x squared minus 192x plus 240 equals 0 with respect to x. And then I'm going to hit enter, and I get x equals -5 or x equals 2. The undefines, well, that's going to be when I have problems here. There's no division, there's no even roots, and there are no logs, so we're never undefined. So that means my only critical values are -5 and 2. So next, let's look at B. If I look at B, I have y equals x minus 2 to the 2/3. Well, that's the same as the cube root of x minus 2 squared, and I write it that way so that you recognize that it's an odd root. So that means my domain has no problems. So all reals will be my domain. So again, I'm looking to see when the derivative of this is 0 or undefined. So I take the derivative, bring down my power, subtract 1 from my power, and multiply by the derivative of the inside. I need to know when this equals 0 or when it's undefined. So the easiest way to do that is to rewrite it as a fraction. This will equal 0 when the top equals 0, which is never, and it will equal undefined when the bottom equals 0, which happens when x is 2. So my only critical value is x equals 2. Final part, part C, we have y equals x minus log base 2 of x squared. So first skill, or first piece, is we've got to figure out what the domain is. If I look at the domain, x causes me no trouble, but here I've got to have the inside of the log be positive, and x squared is what's inside. So if I put a negative number and square it, the positive number will still be inside. So the only thing that I can't use is a 0. So my domain can't have 0 in it, which means when I take my derivative, I've got to toss 0 out. It's not going to be a critical point if it shows up. So to find the critical values, I will take the derivative, which is 1 minus 1 over the inside. Now because the base is not an e, I have to put that log natural of the base. Then I multiply by the derivative of the inside. If I simplify that, I have a 1 minus a 2x over an x squared ln of x. I can cancel one of those x's and get a 1 minus a 2 over an x, oops, sorry, that's an ln of 2, times an ln of 2. Now, finding out when this equals 0 or undefined will be easier if I have a single fraction. So I'm going to get a common denominator, rewrite this as x ln of 2 over x ln of 2, and then I can put them together. So now single fractions will equal 0 if the top is 0, and they'll be undefined if the bottom is 0. So bottom will be 0 when x is 0, but I can't use it because it's not in the domain. And fractions will equal 0 when the top equals 0 means I need to solve for when x ln of 2 equals 2, which occurs when x is 2 divided by the ln of 2. So I have only one critical value, and it is 2 over ln of 2.